What did I say in the
Tell
last
people to
session?
submit you said our homework we must submit question 2
Yes,
and question 4. Yes, minimum must be 10 or 11 people
yes.
submitting.
But now I'm
Yes,
saying that, okay, we want to draw this graph here. Where do we start? Guys, okay. I say we start with our parent function. What is our parent function for this particular graph here? For this particular function, y is equals to 1 minus 2 square root of x plus 3. What is our parent function? Hello?
2 square root x plus 3.
Parent function?
Ma'am, we start with... Oh,
Yes?
I was
We
saying
start
we
with,
start with our mother graph,
which is?
which is y is equals to square root of x.
Thank you. That's where I started. I said before you start with your transformations, I hope it's a recording. I said before you start with your transformations, you start with the parent or the mother function. That's what I said, right? I said for a parabola, you have y is equals to x squared. That's your parent function. And then you do the whole transformation. For a square root function like this, you start y equals to square root of x. For an absolute value function, you start y is equals to, what's this? Absolute value of x, and then y is equal to x for your straight line function. So then those are what? Are parent functions. Some people call them mother functions. So before you do any transformation, you will start with the parent function. In this case, because it's a square root, our parent function will be y is equals to square root of x. And by drawing that graph, we know that, okay, let's draw it here. We know that our parent function would look like this. This is y equals to square root of x. Let's call it y1. y1 is equals to square root of x. Now then we can start with the transformation. So when it comes to the transformation, whichever you start with, it doesn't matter whether you can start with the stretching, vertical stretching, horizontal stretching, or whether you start with the vertical shifting or the reflection or whatsoever. It doesn't matter. At the end of the day, you will end up with the same graph. Now, for example, right? In this part here, we'll start differently to the way how I started in the solution. So let's do a stretch, right? For me to get a vertical stretch of 2 units, what will be the next graph? From this mother function, what will be the next graph? It will be y equals to what? Guys?
Ma'am, what was the question? I didn't get the question.
So the question is, I want to start with a vertical stretch. Remember I said that to draw this graph from the mother function, this one, the parent function, you can start with any type of, any transformation that is already in this equation there. But for me, I want to start with a vertical stretch. So it means that for me to vertically stretch this graph by 2 units, what should I do to this graph, the parent function, y equals to square root of x?
You should shift it 2 units up.
The stretch.
Yeah. It's like
Someone else? Yes, it'll be y.
y equals to square root of x plus 2.
No.
Wrong.
Try again. Guys? Okay, this is what I'm going to do now. I'm going to explain this part. And then if we have a problem like this for the next discussion classes, then we will stop the discussion classes. Because the discussion classes are there to help you. And if you don't look at the videos and then you don't do the work, then it means that we won't be able to continue. Do you all agree with that? Yes
Yes.
or no?
Yes.
Okay, thank you.
Yes.
Okay, so we have the function f of x is equals to y is equals to 1 minus 2 square root of x plus 3. So as I said, in the previous video, I said that for you to actually draw this graph without using points, substituting points, you have to start with the parent function and then do the transformation. In our case, our parent function is y equals to square root of x, right? So you then go to your Cartesian plane and draw y is equal to square root of x. So let's draw that. So we know that y square root of x is a function like this. It's a graph like this. So they said label it. So this will be y square root of x. Now, this 2 over here, it means that you have stretched the graph vertically by 2 units, right? So to understand that, you have to go to the previous video and then check and then go to your notes. So if you say you have stretched the graph vertically by 2 units, it means that you took this graph, this function over here, the parent function, and multiplied by 2. So this became y equals to 2 square root of x. So this means that you have stretched the graph vertically by 2 units. So that means that this point here, 0 times 0, you multiply it by 2, you get 0. This point here, you'll multiply it by 2, it will be somewhere here. This point here, for example, it will also be somewhere in here. So it means that you're stretching the graph by 2 units. So then, drawing our new graph, it will look like this. So this is y equals to 2 square root of x. I'm done with this one. Okay, let's do inside here. Right? Now, this means that I want to take this graph here because I only have 2 square root of x, and I want to have 2 square root of x plus 3. So from the transformation that we did last time, we say that inside, if we have x plus 3, we say this is a shift of the graph horizontally to the left, meaning that we're going to shift the graph horizontally 3 units to the left. So then it means we have y is equals to 2 square root of x plus 3. So we're going to shift this blue graph 3 units to the left horizontal. So basically we're shifting it horizontally. So these are the y-axis and these are the x-axis. So meaning that we're moving it to the left. So how many units did they say we are moving it? We're shifting it? We're shifting it 3 units to the left. So the blue graph will be shifted 3 units to the left. So it'll be, let's say 1, 2, 3. So this is your -3. So all points in this blue graph will be shifted 3 units to the left. So the graph will look like something like this. So then this is y equals to 2 square root of x plus 3. Now, going back to this equation here, you will notice that there's a negative in front of 2, this negative here. And we say that if you have a negative, if you have y is equals to f of x, and you multiply by f of x by a negative, what did we say that is? Does anyone remember? Does anyone remember? Okay. I'll just explain that. So we say this is a reflection of the graph about the x-axis. So it means in the textbook, they'll say the reflection of the graph in the x-axis. So if we take the purple graph, okay, let me use a red color. If we take a purple graph, this purple graph, y, and then put a negative next to 2. So this will be y is equals to negative 2 square root of x plus 3. It means that we're going to reflect the purple graph in the x-axis. So it will be something like this. So the red graph is actually the reflection of what? Of the purple graph in the x-axis. So this will be y equals to minus 2 square root of x x plus 3. Okay. Now that we are done with the negative, this negative here, we still have a 1 there. So we said the 1 will then be a vertical because it's positive. So this is a vertical shift 1 unit upwards of this new red graph there. So let's say green. So now we add 1 to the red graph. So this will be y equals to 1 minus 2 square root of x plus 3. So we are moving every point on the red graph 1 unit upwards. So let's start with this point. So now it means this point will be somewhere here. 1 unit, let's say this was 1. So that point will be somewhere here, 1 unit upwards. So every point in this graph will be 1 unit upwards. So let's say maybe this point will be somewhere there, this point will be somewhere there, that point here will be somewhere there, that point will be somewhere there, because all these points in the red graph have moved, have been shifted vertically upwards by 1 unit. So then it means this graph will be something like this. The graph y is equals to 1 minus 2 square root of x plus 3. So you can also write this point as negative 3 and 1. Do you understand how I drew the graph?
Yes. Simply, ma'am, you're saying that 1 affects the whole functions and 2 doesn't affect the one. Ne? Does it?
2 only stretches. So if you go back to your notes and the previous video, you will see that these 2. So if you look at the transformation, this one shifts the graph vertically 1 unit upwards. This 2 stretches the graph, right? Stretches the graph. This 3 shifts the graph horizontally to the left, and this negative reflects the graph on the, what's this? It actually reflects the graph on the x-axis or in the line of the x-axis. So if you understand your shifting, what's this? If you understand your transformations, then it's easier for you to just get what's this? If I give you a function and say sketch, then it'll be easier for you to sketch. But if you don't understand your shifting, your vertical shifting, horizontal shifting, your transformation, if you don't understand your vertical, basically all your transformation, that is your vertical shifting, your horizontal shifting, your stretching and your shrinkings, your reflections about the x-axis and the y-axis, then it will be a problem for you to understand this, on how to draw this graph without using points. So if I were to ask you again to draw it, and if you use point, then I'm going to give you 0 because I asked you to use transformation instead. Does that make sense?
Yes.
Okay. So now, are we all sorted, guys?
Sorry, ma'am.
Yes.
I want to understand this one. How did you please explain again?
Okay. Before that, is there anyone who also has a problem? Okay. Now, we are asked to draw f of x is equals to 1 minus 2. I'm just going to be very quickly because we still have a lot to do. X plus 3. Now remember, I said, for you to understand on how to draw without using point, you have to do what? You have to make sure you understand your transformations. So it means that you have to go back to the previous video and also the notes in your textbook and then read. Then you'll be able to draw this graph. So I'm just going to repeat it. And then if you still don't understand it, go back to the work. And then in the next discussion classes, we will go through it if you still don't understand it. So now I said that to draw a graph using transformation, you start with the parent function. In this case, the parent function is y is equals to square root of x. Now, let's draw y is equals to square root of x. So this is the y-axis, this is the x-axis. So we know that our square root of x is a graph like this. So this is y equals to square root of x. Now, once you understand your transformations, then it becomes easier for you to then go to the next step from the parent function. So you can start with any transformation that is in this function. In this case, I decided to start with stretching the graph vertically by 2 units. It means that I move from this parent function and to y is equals to 2 times square root of x. I want to start with this 2. So 2 times square root of x, it means I'm stretching the graph vertically by 2 units. For example, this point here, if you multiply by 2, it will remain 0. It will remain 0. But this point here, let's say it was 1. If you are stretching it, you'll be multiplying by this 2. Then it will become what? 1 times 2 is 2. So it will move from, let's say this was 1. It will move from 1. It will be somewhere here. Let's say this point here was 4, for example. If you multiply by 2, it will become what? It will become 8. So it will be stretched by 2 units. So your graph will be something like this over the parent function. So y is equals to 2 square root of x, right? Now that I'm done with the 2, okay, sorry about that. So 2, y is equals to square root of x. That's where we started. Now that I'm done with the vertical stretching, I want to move to the next transformation. I can choose any, but in this case, let's say I choose this one where there's plus 3. Remember, the mother function or parent function doesn't have x plus 3. It only has x. So it means that this one also has x as well. So I want this to be y equals to 2 times square root of x plus 3. From the previous video, as well as the notes from the textbook, we noticed that this here means what's this? It means a shifting of the graph horizontally. It means you are shifting it along the x-axis. So you're going to shift horizontally to the left, not to the right. Just because there's a plus here, don't assume it's to the right. To the left. And to understand that, I'm saying it again, go back to the previous video and your notes. It will really help. So we are going to shift the graph here 3 units to the left. It means that this point here will move 3 units to the left. So let's say this is 1, 2, 3. So it will be somewhere here, 3 units to the left. So every point on the green graph, remember we moved from the black graph, we went to the green graph, and from the green graph, we performed the transformation and went to the purple graph. So it means now we are drawing the purple graph. So we're shifting the green graph 3 units to the left. So all the points in the green graph will move 3 units to the left. All these points will move 3 units to the left. Then it means we have something like this. So then we have y equals to 2 square root of x plus 3. But we are not done. There's a negative next to 2. What does that mean? If we go back to our transformation, we notice that if you have y is equals to f of x, and you multiply the f of x by a negative f of x, this just means what? It means that the graph was reflected in the x-axis, right? Or about the x-axis. So meaning that our new graph, if we multiply this 2 by negative, so we have y is equals to negative 2 square root of x plus 3. It means that this purple graph was what? Was reflected about the x-axis. So remember, the reflection just means the mirror. So meaning that this line here, our x-axis is the mirror, right? So then our graph will look something like this. So then this will be y is equals to negative 2 square root of x plus 3. Are we done? No. There's a 1 here, this one here. Based on the transformations as well, it says that if you have y is equal to f of x, and you say y is equal to f of x, let's say plus 1, it means that you have shifted the graph vertically by 1 unit. But if then it was y is equal to f of x minus 1, it means you have shifted the graph vertically downwards by what? By 1 unit. So in this case, our 1 is positive. It means that the red graph is choose this color. So this graph here will be y equals to 1 minus 2 square root of x plus 3. So it means that you are shifting the red graph vertically 1 unit upwards. So this point here of this red graph, y equals to minus 2 square root of x plus 1, you're shifting it 1 unit upwards. So it will be from here, let's say 1 is up here. So it will be here, right? So every point in this graph will shift 1 unit upwards. Every point will shift 1 unit vertically upwards. Then the graph will become something like this. And you can also write to this point if you want, 3 and 1. Did you see that, guys? Hello?
Yeah.
Okay, thank you. Now, our next question, what did it say? So if you go to if we look at the notes here, not the notes, the solution, you see that I started with the parent function, which is red one, right? And then I chose a different transformation to the one I'm showing you here. So as I said, the type of transformation that you choose doesn't really matter where you start. So in this the solutions, I started with actually shifting the graph horizontally 3 units to the left, horizontally 3 units to the left. So that's what I did. So I moved from the red graph to the blue graph. So I shifted the graph horizontally to the left. Do you see that? Then you obtain this blue graph here. From the blue graph, I then multiplied, from the blue graph, okay, something is missing here. So the red graph is the parent function, and then the blue graph, you have shifted the graph 3 units to the left, and then I multiplied by 2 to reflect the graph, right? I multiply by negative 2 to stretch and reflect the graph about the x-axis. Then I shifted the graph 1 unit vertically upwards. Then you obtain the purple graph. So the transformation doesn't really matter where you start. At the end of the day, you'll end up with the same answer. I will all sort it there.
Yes.
Thank you. Now, on the different system, what did I say system? On the different sets of x's, sketch the graph, which is a reflection in the y-axis of the graph. So now, we know that this is our graph. So we know that our graph looks like this at the end of the day, after performing the whole transformations and then drawing y-axis. This is what we obtain. right? So now they are asking us to reflect the graph about the x-axis. It means that your y, this line here, will be your mirror. So if you reflect, it means this point will be somewhere here. This point will be somewhere here. This point will be somewhere here. Something like that. Does it make sense? So when you reflect it, so about the line y, about the y-axis, the reflection will look something like this. So meaning that this point will be 3 and 1. Are we all okay? It's not drawn on to scale though.
Ma'am, I have a question.
Yes.
Does it always applies in the x-axis, or does it applies in vertical? I mean, in the horizontal. If you are reflecting y-axis, does it same applies on the y-axis?
Please repeat your question.
Like if you are reflecting on the x-axis, like you said, 3 went from -3 to 3. Does it always it applies on the x-axis? I mean, y-axis. I mean, yeah.
Okay, so there's a reflection about the x-axis and there's a reflection about the y-axis.
Okay.
So that's why I'm saying it's important that you know the transformations. Then this work becomes pretty much easy. So if they tell you to reflect about the x, let's say I have the second here, right? And they tell you these are the y-axis, these are the x-axis, and they tell you to reflect about the y-axis. It just means that, remember the mirror. If you look at yourself in the mirror, you'll see exactly the same, but on the other side, isn't it? On the mirror. So if they say reflect about the y-axis, they just mean that this is your mirror and you see this will come this side, basically.
Okay.
Because it's a reflection. It's a mirror image. If they say about the x-axis, it means this will be reflected here. Does it make sense now?
Yeah, it makes sense. Yes.
Thank you. So meaning that our 2.2 solution will be something like this. So we have y, x. We know that our original graph is something like this. The one we obtained in 3.1, -3 and 1. So our reflection about the x-axis will be the green one. So it's not drawn to scale, but it's something like this. So this will be 3 and +1. So that's 2.2. Let's go to 2.3. So that's the graph, basically. Now, 2.3, they say, write the equation of the reflected graph. So they're asking you to write the equation of the red graph that we've drawn here. So, to do that, we say, this is 2.3. We have learned that if you're reflecting the graph about the x-axis, I mean, they said y-axis, right? So you have y is equals to f of x. So for us to reflect about the y-axis, it means we'll have y is equals to minus f of x. Someone might say, okay, fine. How do you see that? When you draw a graph, let's say f of x is here, right? For every point that you get for this f of x, let's call this f of x. For every point that you get, let's say you substitute, you'll get a positive y. You substitute, you get another positive y. You substitute in f of x, get another positive y, right? But when you reflect it about the x-axis, those positive y's, they what? They become what? They become negative y's. Okay. Does it make sense, guys?
Yeah.
Yes. So those positive y's, they become negative y's. Because here, when you substitute here, you'll get, let's say you're getting only positive y, you're getting 1, 2, 3 after substituting. It means your graph will be somewhere here. Ne? Now, let's say you substitute the same values now because it's negative f of x. You substitute the same values. So it means that every time you substitute on f of x, if you get 1, you'll multiply by a negative. So it means that now those values will be somewhere here. It will be negative y, negative 2y, and negative 3y. So it will be the same image that you got here will come here because you said negative f of x. So this is a reflection about what line?
Y-axis.
X-axis.
Please try again.
Y-axis.
No,
It's X-axis.
thank you. Because this is the image of this, and this line perform as a mirror, x-axis. Now let's move to the next one. If you draw a line like this, you have y is equals to f of x. Now you have y is equals to f of x minus f of x inside. Let's say you were choosing positive x's. You were choosing 1 here, you're choosing 2 here, and you're choosing 3 here, and you draw some graph here. Ne? Because you were choosing positive x values. For this one, which values, positive or negative x values, are you substituting in f of x? Guys?
Negative X-axis.
Negative x values. And your negative x values, why are they? They are this side, isn't it?
Yes.
So it means you set negative 1, negative 2, negative 3. So meaning that this image will come here. And that will be a reflection about what line?
Y.
Y-axis.
Thank you. So we were asked to draw a graph of the reflection about the y-axis. Our graph moved from this side, went to this side. Let's say the origin part. That 3, it was negative 3 and 1, that point, and then it moved to what? 3 and 1. So meaning that where you see x, you put negative x because it's a reflection about the about the y-axis. So in your original equation that you have for y is equals to 1 minus 2 square root of x plus 3, because it's a reflection about the y-axis, which is what we're performing here. Y is equals to f of x minus x. So the reflection about the y-axis is represented by f of negative x. If you had y is equals to f of x, and you're reflecting that graph about the y-axis, then it means that you write it as y equals to negative f of x. F of x, y is equals to f of x, y is equals to f of negative x. So it means that where you see x in this graph, you put negative x. So let's write it. Our original is y f of x equals to y minus 2 square root of x plus 3. So the reflection about the y-axis, we know that it will be y equals to negative f of x. So then this is equals to 1 minus 2 square root of negative x plus 3. So therefore, the reflected function, meaning the graph that we drew previously in 2.2, its equation will be y is equals to, let's call it h of x equals to 1 minus 2, 3 minus x. Are we all okay there?
Yes.
Yes, ma'am.
Thank you. Okay, now we can move. So this is the equation of this graph over here. So I said question 4. Okay, here. Now, as I said, if you understand your transformation, it becomes easier for you to do what? To actually write the function. So here, you are given the parent function and they want you to perform the transformations and write the final equation. So how do we do that? So they are saying that 4.1, f of x is an absolute value of x. So we see that this is an absolute value function. And they say we shrink vertically by a factor of 2. So what does that mean? It means that if we're going to shrink vertically by a factor of 2, so we have y is equals to f of x is equals to square root of x, right? Now they say shrink vertically by a factor of 2. Go back to your notes if you don't understand. Remember what we said. If you are stretching or shrinking the graph vertically, it means that just here, you have to multiply by a constant. And if you multiply by a constant that is between 0 and, what's this? That is between 0 and 1, then you are shrinking the graph. That's what we said. But if you multiply by a constant that is greater than 1, you're actually stretching the graph. That's what we said in the previous graph. I mean, in the previous discussion class. So here we are asked to, what's this? To shrink the graph vertically by 2 units. So basically it means that we're just multiplying by a half to the original equation. So let's call this h of x, right? Now the other step, the second step was we do what? We shift to the left 1 unit, right? So remember what we said from the previous discussion class. We say that if you have y, if you have y is equals to f of x, right? And you want to shift c units to the right, for example, c units to the right, it means that it will be y equals to f of x minus c. Then you have shifted this graph, what's this? You have shifted this graph horizontally to c units. You have shifted the graph horizontally to the right by c units. If you have y is equals to f of x plus c, it means that you have shifted the graph horizontally to the left by what? By c units. So here we are asked to shift the graph to the left by 1 unit, meaning that we shift to left by 1 unit. So it means we take this graph h of x. So let's call the new graph g of x. This h of x will add plus 1 because we're shifting the graph 1 unit to the left. So then this becomes what? 1 over 2 x plus 1. What's another transformation? And then they say shift upwards 3 units. So meaning that we're shifting it vertically 3 units. Shifting it upwards by 3 units, vertically upwards by 3 units. So this means that, so we shift, now here, let me choose a different color. Okay. So we shift upwards 3 units. So meaning we take this graph, let's call the new graph R of x. So this graph will then be 1 over 2 x plus 1 plus 3, because we have shifted the graph, what's this, 3 units upwards. So this is what you were supposed to get for your 4.1. Are we all sorted?
Yes.
Yes,
Okay.
ma'am. It's yes, ma'am.
Oh, okay. I had a no. I had a no from someone.
No, it was a yes, ma'am.
Oh, okay. So now, if you still don't understand, remember, you can go back and come back to this video and then check where you don't understand. If you still don't understand, come back to me and send me an email. I'll help you. Now let's go to 4.2. So that's the graph. That's the graph. X-axis shift 1 unit upwards. Can someone try, guys? Can someone try? Because you have f of x is equals to square root of x. So they say reflect. What do you think the graph, the new function will be? What's going on today, guys?
You are saying how is it reflected?
Please. They say we perform this transformation reflecting the x in the x-axis and shift 1 unit upwards. What do you think the final function will be?
Can I try?
Please.
The final, I think it will be negative square root and then x plus 1.
So you're saying it will be the new function, let's call it r of x, will be what?
Negative square root x plus 1.
Thank you very much. Guys, your energy also affects me. So the more you perform, the more we'll perform together, you see. Thank you very much. Do you all understand how we got it? Does it make clear now? What am I saying? Does it make sense now?
Yeah.
Good. So they are saying reflect in the x-axis. Remember we said if you have y is equals to f of x and you're reflecting in the x-axis, it means you're just multiplying in front of f of x, you're just putting a negative. So that's what he did. So then he got y is equals to negative square root of x. And then they say shift 1 unit upwards. So it means that from this graph that you obtained here, you just shift 1 unit upward. Let's call this graph r of x. So this becomes x plus 1. Now we are moving. Now that you understand, I want you to go and try again the work. Now they say we have f of x square root of x. Reflect in the y-axis, shift 2 units downwards. Can someone help me? Hello?
Yes, ma'am. Okay, it will be. Can you hear me?
Yes.
Yes, it will be. F at x is equals to the square root of minus x.
Yes.
Minus 2 because it's shifting 2 units downwards.
Does that now are we getting it, guys? It's important. Are we getting it now?
Yes.
Thank you.
Yeah.
So next time, please make sure next time you don't come to the discussion classes without looking at the previous video and the previous video and the homework that I gave you, because then this will become much easier and we'll move faster. Thank you very much. So they are saying that we have this parent function. You see, we started with parent function in every equation. Before I talk about parent function, let's solve this one. They say reflect in the y-axis. And what did we say? We say that if you have x, y is equals to f of x. This is also in your text. and previous video. Then if you are reflecting about the y-axis, you're just saying negative x. Where you see x, you put negative x. So meaning that from the parent function that we have, this graph here, where we see x, we put negative x. Let's call this h of x. So this becomes negative square root of x. But they say we also move 2 units downwards. So it means we'll just minus by what? By 2. So this graph becomes y equals 2 square root of minus x minus 2. Are we sorted now?
Yes.
Yes.
Thank you. So that was the homework, last week's homework. No, last week homework. Do you need 5 minutes because we are starting this week's notes? Guys? Do you need few minutes to resting in? Because we are starting this week's notes. Or is there any question before we start this week's notes?
Yes. Well, can I get the link from the previous video?
Guys, before that, can you please admit everyone who's trying to enter the group? So the link is on my UNISA, right? But now the link I'm going to, you see here, this group, like I'm going to post on the chat. Even later on, you see that you post here and then you can get the link. But definitely on my UNISA under announcement. Check your my UNISA every week. If it means twice a week, check it. I posted the links there.
So far we had only one video and this second one now.
We are having 3 videos. So there were 4. The first one was a consultation, so I didn't upload that one. I canceled it. That work will be covered today. And there are 2, which, yes, 2. Then this one is the 3rd one.
Oh.
Yes. So I noticed a lot of people I have not prepared, and it's affecting me as well. So for the next one, please prepare. Otherwise, the next one, I'll just stop it and then we don't do the work. Please prepare, because then it becomes easier for us to discuss and have fun and make maths fun. Is that clear?
Yes, thanks.
Yes, it
Thank you.
Yes.
Okay, so this is new stuff. Not new because you already did it in the assignment. But then this is work that I'm going to give you homework for next week. Next week's homework, can you please write this down? Are you ready?
Yes.
Yeah.
Question 1.1.
is.
1.5, sorry. We skipped 1.5. Question 1.5. Question 3. Question 5. Question 6. Question 7. Question 8. And question 9. That's the work we are covering today. Did you get that one? Question 1.1. I mean 1.5. Question 1.5. Question 3. Question 5. Question 6. Question 7. Question 8. Question 9. That's I'll tell you when I want this. So we can start with do you want that 5 minutes break or we start?
You can start.
Okay.
Ma'am, sorry to interrupt. You said on which assignment?
It's assignment 2. So after we do what we do today, we are done with assignment 2. So make sure you understand assignment 2. We are done with assignment 2. So it's important that we learn how to find the domains of the function. Very important, right? So now, before we start with anything else, I want us to look at the following functions. They appear frequently in our module. So we have f of x, the forms will appear frequently. Okay, my pen is changing color. X minus 4. Can someone help me with the domain of that function? And before that, if we say df, it will represent it as the domain of f. If we say dg, it means the domain of g. So can someone help me with the domain of f?
Yes.
F of x. Yes.
X minus 4 not equal to 0.
Why?
Yeah, it's gonna be undefined.
Do we all understand there?
Yes.
Okay. And can I please have 3 yeses before I continue? Second yes.
Yes.
Another one. Guys, it's important. Don't be shy. If you don't understand, it's fine. I'll explain it. Is there anyone who doesn't understand? I'll explain it. Yes, no? Guys?
Yes, yes, I understand.
Okay, thank you. But I'll still explain it. So now, the domain of f. So we represent the domain of f like this in this module, right? Is equals to x such that. Now, if you take a calculator, right? And say 1 divided by 0, or 3 divided by 0, or any number divided by 0. Or what from what we have learned is that division by 0 is what? Is undefined. So in this module, division by 0 is undefined. So it means that whatever is under what's this? Whatever is in the denominator. We know that our 1 is the numerator, our what's this? Our x minus 4 is the denominator. If we don't remember properly, we said if we have a fraction, the top part is the numerator, the bottom part is what? Is the denominator. 1 over 2. Numerator is what? 1, denominator is 2. So we are saying that when we are finding the domain, the denominator of the function, if it has a numerator and the denominator, right? The denominator of the function should not be equal to 0. It means that everything here under 1 over something should not be equal to 0. So it means that this, we're saying x minus 4 should not be equal to 0. Then we can simplify and say x such that x, we take the minus 4 to the other side of the sign. So that. So therefore, x should not be equal to 4. Why x should not be equal to 4? Because if you go into this function and substitute 4, where you see x, 4 minus 4, you will see that this will be equal to 1 over 0. That's why we're saying that our x should not be equal to 0 for this particular function to be defined. Are we all okay there?
Yes.
Yes, ma'am.
Thank you. Now, remember your exam is multiple choice, right? So it means that I might ask you, I might write an interval notation. So how do we represent the interval notation, right? Interval notation. So interval notation just means you have brackets, let's say 0 and 1, this is an interval notation. This means including the values, right? How do you write the interval notation for this one? Can anyone help me, please? This one, this domain of f. How do you write the interval notation? Are we all comfortable for moving from here to the interval notation? Because in the exam, I might give you an interval notation. We have to choose from the interval notation. How do we write it? Can anyone try? Guys, it's important to try because then I lose energy if you don't do it. Try.
0 is to 4. I mean 4 is to 0. Bracket
How do you
4.
write it? Brackets, open bracket, this.
Open
I want that.
bracket. Open bracket 4.
Okay. So you say open bracket
4
4,
and comma 0.
comma 0.
Bracket 2. Yeah.
Do you agree?
Let me come in.
Yes, thank you.
I have open brackets,
Open bracket
negative infinity to
Ne-
4,
to 4.
but not including 4.
Okay, so
And
how do I write that?
no, a normal bracket, not a other one.
How do I do that?
Yeah, that bracket is the right one. Open bracket, not that other one, that including bracket.
Okay, so this is fine.
Union.
Union.
Open bracket,
Mm.
4 to positive infinity.
Very good. Do you all understand how we got this?
No.
No.
Okay, so look at this. In the exam, I gave you and say find the graph of this, and I give you these options. You see, we're not going to be able to get the answer.
Yes.
Listen and listen very carefully. Draw a line. Do you remember the line? Number line. Do you all remember a number
Yeah.
line? If you
Yeah.
don't
Yeah.
remember, it's a line. It has 0 in the center. It has -1, -2, -3, -4. 1, 2, 3, 4. Can someone say something, please? Can someone say something before I continue?
Yeah, why
The
we are
negative on the side.
The negatives
The
are?
negative one.
Wrong.
Thank you.
They should be
Negatives.
negative should be on the negative
Thank you.
on the left side.
It means we remember. Thank you very much. So the negatives will be what? On the left-hand side of 0. So -1, -2, -3, -4. 1, 2, 3, 4. If you attend my class, you will notice sometimes I just write something and then you have to correct me because it's a discussion class. So the negatives are on the left, the positive are on the right. It means we remember our number line, right? Now that we remember our number line, okay, why is the eraser not okay? Okay, now that we remember our number line, you go and draw this domain. You see this domain that you talked about here? We said we are all sorted of finding x is not equals to 4, isn't it?
yes.
Guys?
Yes.
Yes. So you go and draw your
Yes.
domain. You can put a 0 if you want to put a 0. Then you know your 4 is here, right? When you say not equals to, remember when you are drawing the intervals, not equals to means a circle, open circle, right? What is your domain saying?
Element
Can
of
someone
one.
help me? My domain is saying that x is any number to the left, any number to the right, but not including 0. I mean, not including 4. Does that make sense?
Yes.
So this x here, it means x is an element of real numbers such that in other textbooks they'll write it like this. Domain of x is an element of real number such that x should not be equals to 4. In other textbooks they'll write it like this. And say such is, remember, from negative infinity to positive infinity, those are real numbers. Those are 1, 2, -0.5, 0.5, 0.002, -0.0 whatever. Those are real numbers. So now they're saying that x is an element of real number such that x is not equals to 4. It means that x is any number on the number line, but not equals to 4. So that's where the function is not defined. Are we all okay on the number line?
Yes.
Yes.
Thank you. So how do you write the interval notation? Okay, let's go to the left of 4. Where is my arrow ending? The red arrow.
Negative infinity.
Negative infinity, isn't it?
Yes.
Yeah.
So it's saying that, remember, you don't include negative infinity. You don't use a square bracket. If I see you using a square bracket, I'll punish you. So negative infinity, my red arrow is pointing at negative infinity. It means that all the values at negative infinity, my function is defined. Therefore, I'm including it, negative infinity. Oh, sorry. Comma. Where does it stop? Guys, where
At
does it
4.
stop?
Positive
At
4.
4, right? At 4. Because there's an open circle, it means 4 is not included. So it stops at 4. Do you see that? Meaning that from 4, not at 4, but from 4 going downwards, my function is defined. Correct?
Yes.
But it is also defined somewhere, isn't it?
Yeah.
Where is it defined? Where is it defined?
From 4 to positive infinity.
But is it including or not including square brackets or open bracket?
Open bracket.
From 4 to positive infinity. So now using English, you're saying that my function is defined from 4 to from negative infinity up to 4, or from 4 up to positive infinity. Does that make sense, guys?
Yes.
You see the interval notation, how we got it?
Yes. Yes. Yes.
Another yes? Guys?
Yes.
Okay. So now, let's do this one. I want you to find the domain of g of x is equals to square root of x. What do you know about square root functions? Remember we said domain what's this? Are all x values such that when you substitute here, you get an answer. What x value can you substitute in here under the square root and not get an answer and get an undefined in under a calculator?
0 than 0.
Eh?
0.
All than 0 will be undefined.
All values that are less than 0, you can't. Is 0 included as well?
Included.
Is it included?
Yes. Yes.
Okay. Before that, I said that the domain, the values in the domain will be all x values such that when I take what's this? That one of those values and I put them in here and I will get an answer for y. So let's say this was y equals to x. If I take a value, I put it in here, I'll get the value of y. Is 0 included? If you get an answer, then
Yes.
0 will be
Yeah, 0 is included.
in where? In the domain.
Yeah.
There we go. Because y equals to square root of 0 is equal to what? Is equals to 0. So meaning that 0 is included. But every value, square root of -1, is undefined in our module. Please don't ask me why I'm saying in our module. It's undefined. So if you see Math 1510 and you find the square root of a negative number, is undefined. Y is equals to square root of -3 is undefined. So y is equal to any negative value inside here is undefined. So can someone try the domain? Now we are moving. You see, now we are moving. Can someone try the domain of this function?
When x is greater or equals to 0.
So d of g, x is x such that x is greater or equals to 0. Do you all agree?
Yes.
Yes.
Another yes? I want 3 yeses.
Yes, we agree.
Thank you. Give me the interval notation. I want you to know all the notation. Interval notation. What will be the interval notation of this one?
From 0 to infinity.
Like this.
Yes.
Can I have a second answer? Thank you for the answer. Can you have a second answer? Guys?
Yes. It's from 0.
How do I write it?
Open bracket 0.
Mm-hmm.
To no, it's fine.
I know someone is like, I disagree. Can that person say something?
Ma'am, I think it's from 0 but close bracket, square bracket to positive infinity with open bracket with the round bracket.
Why? I knew someone is sitting with an answer. Why?
Because of an equal sign.
The 0 is included, but positive infinity we can.
Thank you. Once you say greater or equals to, this means equals to, less or equals to. It means that you are including the value. Therefore, you will need the square brackets. Does it make sense? So the interval notation will be 0 to positive infinity. Does it make sense now, guys?
Yes.
Yes.
Thank you. Now, just to remind, the reason why I'm sticking here, because all the questions they want the domains. Now, how do we draw this on a number line? We go to 0, right? We write a 0 here. And it says from 0, including, so meaning a solid line greater than 0. Do you see? That's why we are saying from 0 to infinity, because our arrow is pointing 0. So that is why we have 0 to infinity. So the domain of G can also be in an interval notation like this. Are we all sorted now? Guys?
Yes.
Then you can use.
Yes.
So if you are getting it, it's fine. Now I have f of x is equals to 1 minus x squared minus x. Can I get an answer?
Yes.
What is the answer? Domain of f?
X squared minus x, not 0.
Domain of f, okay, sorry. F is equals to x such that x squared minus x is not equals to 0. Is this where I end?
Solve for x.
Help me.
To solve for x,
Yes. What do I do?
x is equal to 0.
Like this.
And yeah,
And
x minus 1 is equal to 0. No, not yeah.
Equals to or not equals to?
Not equal to.
Okay.
And therefore x is not equal to 1.
Did you see how you solved it, guys? So this is the final answer.
Yeah.
Hello? Guys, did you see that?
Yes, ma'am.
Yes, yes, yes.
Thank you. Thank you. So what you did is, okay, let's write it on a, instead of erasing, it will take time. So we have f of x is equals to 1 over x squared minus x. If you want, you can just start here and say x minus 1. Factor out x, right? Now then you say the domain of f x such that this whole part, the denominator, is not equal to 0. Is not equal to 0. Just like that, as you solved it. So this is not equal to 0 and x minus 1 is not equal to 0. So then this means that x is an element of real numbers such that x is not equal to 0 and x is not equal to, you take 1 to the other side. That. Thank you very much. Now I want the interval notation. Remember, you have to know all interval notation. Please help me. Give me the interval notation. I want to see the interval notation. Hello, guys. I want to move. Me, I move. If you move my energy, if you answer my energy, you give me energy. Give me energy. Whether the answer is wrong or right, we are learning together. Give me the energy. Yes. Let's talk.
I'll try.
Please try. Did you draw the number line first?
Yeah, yes.
Thank you. Let's do it. Mm-hmm.
And from 0 to infinity.
Okay. Why am I saying the domain of G? So the domain of F is equals to from, oh sorry, we say interval notation.
Yeah.
Let's just write it from 0 to infinity.
And union.
Union.
1 to infinity.
1 to infinity.
Yeah.
Thank you for trying another one. Remember, I want two answers. And then we discuss why we have two different answers. If we have two same answers, it's fine. But if you have two different answers, we need to discuss why. Another
Yes.
answer?
Open bracket.
Open bracket.
Negative infinity
Negative infinity to
is 0.
0.
And union.
Union.
Open bracket 1 to infinity.
1 to 0. And
1 to union. Not. Please cancel that 0 and 1.
okay. Cancelling the 0 and 1. Union.
1 up to
1 up to
infinity.
1 up to infinity.
Yeah.
Is there someone who disagrees with these two? Guys? I know someone is sitting with a third answer here. Please help.
From my side, I disagree with the first one and agree with the second.
You agree with the first one?
No.
Okay. Someone else? Guys? Who else drew a number line? Can you draw the number line?
Yes, I drawn the number.
So what did you get?
I had on the number line, draw a straight line.
Yes. So what did you get the answer?
How did I get the answer?
What answer did you get? Is it the same as one of the 1 or 2?
Oh, I'm the person who got the second answer.
Thank you, Nick. Now let's draw the number line. And you guys help me. Go back, draw the number line. The reason why I'm spending too much time here is because you will be asked to find domains in the exam. There's no way you can write the exam without finding the domain and the what. So I have a straight line. We are drawing it, isn't it? We agree this one is easy to find. So they're saying x is not equals to 0 and x is not equals to 1. So we go to 0 here. And we go to 1 here. So x is not equals to 0. It means it will be an open bracket. And x is not equals to 1. It will be an open bracket. So can someone read? So meaning that my domain will be this number, red line. It will pass here, but will not pass through 0. And it will pass here, but not pass through 1. Isn't that they say not equals to 1? And it will pass like this. Are we all okay on how I drew the domain, isn't it? Guys?
Yes.
Yes.
I took it from here. X not equals to 0 and x not equals to 1. So that's why we have open brackets there. So can someone read where the red line is? And then do the interval notation for this particular domain. Even trying, guys, it's nice. Guys, there's a lot we have to cover.
Oh, then can I try again?
Yes, please.
Okay. Which means it start from negative infinity.
Like this.
Yes. Comma 0. Is it allowed to add 1 and set comma 1 and then or it can say, okay, ma'am, please remove the 0 and say infinity.
The first thing you notice, you didn't correct me on the type of brackets I should use.
Yes,
That's where you were wrong.
I didn't pay attention to that. Sorry.
Yes. So how do I start?
You add a comma.
Okay. So tell me, open bracket, close bracket.
Open bracket.
Open bracket.
Yeah. And then negative infinity.
Negative infinity.
And comma positive infinity.
Positive infinity. Easy, right? Easy, right, guys? Can someone else try again? Reading this line of ours.
Yes.
Yes.
From that number 2.
Yes.
It's a close brackets negative infinity.
Close brackets.
Yeah.
Remember we said with infinity you don't use close brackets.
Oh yeah, yeah. It means it's
Negative infinity. What's this? Open brackets.
negative infinity
Negative
same.
infinity
to 0.
to 0.
Yeah. Union from 0 to 1. It's not undefined.
So from
0 and 1, all the values will be undefined.
why? Where is the red line?
Between 0 and 1.
Between 0 and 1.
Yeah.
Are we done?
And
Can someone help while you continue?
Can you add union again?
Yes.
Yes, and then put 1 to positive infinity and close bracket.
1 and positive infinity. Okay.
not
Infinity and close bracket.
Oh, sorry, infinity.
yeah.
Positive infinity and a close bracket.
You all understand how we got there, guys?
Yes.
Is it allowed from the first place to put 3 like
You
sort
can
of
put 50 millions of them.
Oh, okay.
Look at this. Look at this. This is what I said from you. This is what I said to you from the beginning. If I have a domain, let's say of h of x, and they tell you that the domain is x element of real number such that x is not equals to -1, x is not equals to 2, x is not equals to 7, right? It means you go and draw this number line, right? You draw your -1, -1, you draw your 2, you draw your 7, your 7. So they are saying that x is not equal, let's use this paper line. X is not equals to -1. It means that you will not include meaning it will be solid. So it will be an open circle. Not equals to 2, it will be an open circle. Not equals to 7, it will be an open circle. Do you see that? If x is not equals to -1, not equals to 2, not equals to 7, x is what then? Guys? It means x is anything else. Because remember, they're saying that x, okay, let me write it like this. X is element of real numbers, but let's not say such, but it should not be equals to -1. It should not be equals to -2. It should not be equals to -7, meaning that it can be any number. It can be 3. And where is 3? 3 is here. It can be 1,5, and 1,5 is somewhere here. It can be 0,06, it's somewhere in here. It can be -5. -5 is somewhere here. But it should not be -1. It should not be 2. It should not be 3. So what you are saying is, when you're saying x is an element of any real number, let me choose orange. It means that x is somewhere here. Choose any number somewhere here, but not equals to -1. Where you get -1, you stop. You jump. From -1, you choose another number from between here, but it should not be 2. After that, you can also choose another number from here, but it cannot be 7. And then the arrow points that twice, and means that you can choose any number to that point. So meaning that our domain of h of x is any number from 0 to every number this side, or numbers between 0 and -1 and 2, or numbers between 2 and 7, or numbers greater than 7. So how do you represent the domain of h of x in an interval notation? Not a set. This is called the set notation, this one. the one we have been writing here for the set notation. So the interval notation, it means that you say that negative infinity, because you see this arrow here, the first one is pointing, it's saying from negative infinity to 0. So it's open bracket. Remember, we said we don't include negative infinity. So it'll be negative infinity to 0. Open bracket. Open, it means your circle is open, right? Where else is the orange line? The function, the domain, this one is defined here. The function h of x is defined here before. The function of f of x is defined from negative infinity to 0. This is where the orange line is. Or, remember, the union means or. This means or. Or, the function is defined between -1 and 2. Or, the function is defined from between 2 and 7. Or, the function is defined at 7 and infinity. Do you see that? Guys?
Yes.
Thank you.
Right.
Now, it means that we need to go back. We need to go back and draw our function. The number line is important that you understand it because we're going to use it very often for the next work. So here it says, sorry about that. Here it says x is not equal to 0 and x is not equal to 1. So you go and draw your number line. 0 is here and 1 is here, open bracket here. So meaning that with the red line, you are saying that the function is defined from is here. It stops here. It's like a car moving from the left-hand side. It stops here, right? Because they are saying it's not in the domain. It then skips 0, and then it starts from a number after 0, whether it's 0.000000001. It's still fine. It starts the number from 0. It moves, gets to 1 and say, 1 is not included. It means it skips 1. It goes to a number after 1, even if it's 1, even if it's 1,0000000 million zeros 0.2. I mean 002. It's still a number after 1. And then it moves forward continuously. It means that my function is defined from all the numbers before 0. And how do you write all the numbers before 0? You say open bracket negative infinity. And then it comes and stops at 0. 0, because it's not a solid bracket. If it was like this, then it would be a square bracket. But because it's like this, then it's an open bracket. So now, because we have this here, it's an open bracket. It means we are not including 0. Then we skip 0, or the function can be here, can be defined here. So it means that's the or 0 and 1. And then we skip 1, we don't include 1. Or the function can be defined after 1. So meaning it's or 1 and positive infinity. I will all sorted there.
Yes, sorted.
Yes, ma'am.
Good. Now one last one. One last one. You see, if we don't move, guys, from the beginning, we can't cover today's work. So next time, please prepare. Can someone give me the domain in a set notation? This is a set notation. X such that please help. Let's move, guys. We have work to do. We have work to do. Otherwise, the homework will do it without work, without me giving you the notes. Come, let's move.
9 minus x squared is greater than 0.
Good. Another answer? Another one, please. Okay, I'm writing the one. Yes.
When x not equals to 3.
But that's a square root. It's not a denominator. It's not a fraction.
Can't you like rearrange and then it'll give you a perfect square?
You can, but I just want you to take it from the graph. It's exactly because the previous student said 9 minus x squared should be greater than 0.
All
That's
right.
what he said. Because we said everything under the square root should be what? Can someone remind me? Everything under the square root should be what?
Positive. Greater than 0.
So what's the domain of this? What's the domain of f of x is equals to square root of x?
X greater than 0.
X greater than 0.
Yes.
Guys, there's something you're missing.
X
Uh,
okay, equal to 0.
Thank you. X greater or equals to 0. So we're saying anything under the square root would be x greater or equals to 0. So what will be the answer inside here?
9
What are we
minus
missing?
is greater or equal to 0.
Thank you. 9 minus x squared greater or equals to 0. Are we all sorted now?
Yes.
Thank you.
So, ma'am, can I ask?
Yes.
It's correct if you can rearrange it and then solve it. I mean, and because it's a perfect square, and then simplify it and then when you get 3 and 3, and then is it also correct if you do that?
It's not it's not only correct, it's 100 and over 50% correct. 100 and we know percentage is 100, but you're giving me 200% correct. Because you're not leaving it like this. You have to solve it. You are correct, but you're not leaving. You're just saying everything under the square root should be greater or equals to 0. That's what you're saying. So if you leave it like this, I'm not going to give you an answer. I don't know what that is. You have to solve what you're saying right now. X such that if you rearrange it, let's say x squared plus 9 greater or equals to 0 equals to x such that, let's say you multiply by negative, so negative, this will become x squared plus minus 9. Can please someone help me? X squared minus 9 minus 9. Hello?
Open bracket x.
Before that,
Oh,
isn't that we multiply by negative 1?
yeah, and that's
So we
about
have x squared minus 9
Greater or equal to 0.
greater or equals to 0.
Yeah.
True or false? True or false? False. Why?
I want to understand. And if you divide by negative, does it affect the equal sign?
So what do you think? If let's say if it does affect the sign, what do you think the answer will be?
Will be less than or equals to 0.
Thank you. Guys, remember your basics. If you have greater or equals to and you multiply by negative 1 or divide by negative 1, your sign changes as well, becomes less or equals to. If you have a greater than, you multiply by negative 1 or divide by negative 1, it becomes a less than. Does it make sense now to everyone? Are we all
Yes.
on the same page?
Yes, it does.
Thank you. So now, difference of 2 squared. We are factorizing, isn't it? X. What is this? Please help me.
Negative 3
Negative 3
plus 3.
plus 3. Do you remember how to solve inequalities?
Yeah.
Okay, so this will be, please help me.
X less than or equal to 3.
X less than or equals to 3.
Yes, and x less than or equal to -3.
And x less than or equals to -3.
Yeah.
Okay. Does someone else can
Ma'am,
someone else?
can I correct?
Yes.
Like, is x less than, I mean, x less or equal to -3, and x greater or and x greater or great. I mean, x greater or equals to 3. Yeah. Okay. I think it's like.
Can I have a third answer? Guys, I noticed inequalities. It's part of your work. You know that your exam is on. Okay, let's start here. Do you remember how to solve inequalities?
Not really, ma'am. Can you give us like a crash course on inequalities, because it confused me when you get there.
Okay, so I'll give you a course. Okay, let's start here. You see when you get here, you see when you get at this point, you have to solve the inequality. You go and do rough work. I call it the rough work. And solve it the way you used to solve it in grade 12. And this is how one of my teachers taught me. They said that you have x squared minus 9, isn't it? Less or equals to 0, isn't it? Do you remember that one?
Yes.
Yes.
Before I remind you that one, I go back to my friend, the number line. 0, 1, and -1. Isn't okay, let's put here -2. Which one is greater between -1 and -2?
-1.
Okay. Which one is greater between 1 and 2?
2.
Yes, thank you. Are we all on the same page, right?
Yes.
Thank you. Go back to our inequality. So we factorize. Tell me the difference of 2 squared. This is 3. Okay, this is 0. Why am I saying 3? My brain. X minus 3 plus 3. Are we all together there?
Yeah.
Then you find
Yes.
critical values. You say CV. How do you find critical values? You take what's in the bracket and equate to 0. But you don't put it here. You say x minus 3 equals to 0. X minus 3 equals to 0. Then x is equals to 3. X plus 3 equals to 0. Then your x is equals to
-3.
-3. So these are your critical values. Then you go and draw a line. I like this thing called number line. Right?
Yes.
So this is 3, this is -3. Am I correct on how I placed it?
No.
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 Help me then.
Minus should be on the left.
Thank you. Right? It will never change. If you have a quadratic function, let's say you have x squared plus 9x plus 3 less or equals to 0 or greater or equals to 0, and you factorize. What I'm going to do right now will never change. It will always be like that. Next. So what you do, you have these two numbers, isn't it? You
Yeah.
then say plus, minus, plus, always. Do you see that?
Yes.
So if we had 2 and 7, you still say plus minus plus. Are we all okay on that one?
Yes.
Now, our sign here says less than. Positive or negative? What do you think? Would it say positive or negative if it says less than?
Negative.
It means you are focusing here, inside here. Do you see that?
Yes.
Yeah? And then if you're focusing inside, you put an X here, inside there. You see, I'm putting a small X. I don't want to put it on this. You put an X in there, right? I want it to be clear so that we don't make mistakes anymore. So it says less than here. It means you look at the negative part, which is here. Ne? You go put your X here. A small X there. Right? So X represents any number. Now, if you were a shark, would you eat a bigger fish or a smaller fish?
Bigger one.
Bigger fish.
A bigger one. So let's assume this less or equals to is a shark. The sign of ours is a shark, right?
Mm.
A number here that is represented by X and a 3. Which one do you think a shark will eat?
3.
3. So it means the shark mouth will go this side. A number at -3 and at X, which one do you think it will eat?
-3.
Hmm?
-3.
Wait. A number at 3 and X, which one do you think it will eat? Between 3, -3 and X.
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 So the shark will eat X. You see what I just drew here? You see that one?
Yeah.
Yeah,
You bring it
okay.
here. -3. And then you go and erase here. And that's your answer. Did you see how I got my answer?
Yes.
Yes, ma'am.
Can
Ma'am,
someone try? Yes?
does it work on the if the inequality sign is greater or equals to
Let's see.
0? Does it also apply
Greater
to
or
shark?
equals to 0. Okay, no, we are not going to be asking such questions. We are going to do such questions. Greater or equals to 0. Now it's greater or equals to 0. Help me. Where do you think I focus?
Mm.
Where do you think I'll put my small x?
In the middle. Is it?
In between -3 and the +3.
In between.
Yes.
Why do you put it in between? Because now the sign is greater or equals to.
X.
Where do we put it?
It's 0.
Remember, you have plus, minus, plus.
Mm,
It said less or equals to. We put it when minus is. Now it says greater or equals to. Where do we put it? Guys, please help. Today's session is taking longer. We need to work. Continue. Please help. Where do you put my x?
Between 0 and +3.
It's not between -3 and 3.
No, because remember we said less or equals to, we took our x, we put it here between. We said less or equals to, it means we go where the negative is.
Between 0 and -3.
Mhm.
Oh. 3 and 3 infinity.
So I put my x with 3 and infinity.
Yes.
Yeah, I'll put my x here. Right? Is there only? Is that where I put it only?
And 0 and -3.
No? Where else? You don't see 0 and -3. It's -3 and 3.
And the
Negative
infinity.
-3.
Between?
Negative infinity and -3.
-3. Because it's saying greater than, you go where there's a positive. Do you see that? So where is the positive? A positive? It's between -infinity and 3, and also between 3 and what? And positive infinity. That's where there's a positive, because it's saying greater or equals to 0. If it was saying less or equals to 0, that's where we put it here between the -3 and 3. After putting x, what do we do? What do we say? Guys?
The shark will eat 3. Okay.
Wait. Remember, we are focusing here.
On negative. Oh, the shark will eat eggs.
Do you all agree the shark will eat eggs?
Yes,
Why the shark will eat eggs?
because it's bigger than.
Remember, x represents a number less than 3. Here, x represents any number greater than 3. So, would it eat x or -3?
Eggs, because x is smaller.
Someone said something.
-3.
Why
It will eat
-3?
3 because the x, it might be -4. So the -3 comes before the -4.
Thank you. It means the shark will eat what?
-3.
-3. So it's greater than or equals to, because here it's there's an equals to there. So here and here, which one would it eat? But now at 3 and x, which one it would eat?
X.
X. Do you see that? So meaning that you take it the way it is. This one, you write it as x less or equals to -3, or this one at x is greater or equals to 3. That's how you solve your inequalities.
Thanks.
Does it make sense now?
Yeah, it makes sense.
Yes, it does.
Okay, so
Something-
let's choose a value here. Let's see if this is correct. We're saying we want values at 3 and less than -3 to make this statement correct. So we're not going to choose -3. Let's choose -4. If we put -4 here, -4 minus -3 and -4 minus +3. So this will be equals to -7 times -1. So -7 times -1, it will give me +7. You see that value is greater than or equals to. So it means that our statement is correct. So now you see how you're going to do inequalities, isn't it? Guys?
Yes.
Yes.
ma'am.
Yes.
Thank you. So let's go back to our question. Today's session is dragging, guys. It's worrying me because we haven't covered the work that I want us to cover. So it means that you go back and say, okay, I factorize less or equals to 0. It's what is x 3 minus +3. So critical values are -3 and 3. Draw your number line. So you say -3, +3. Remember what I said, you say plus, minus, plus. because this is less than, it means you're going to focus on the negative between 3 and x. Then you put an x here. So if there's a number, x represents any number between 3 and x, it means that this number x will definitely be greater than, will be greater than what? Will be greater than -3. So the shark will eat x instead of -3, meaning that if we choose a value of x, x will be what? Let's say 2, right? Here as well, the shark will what? The shark will eat 3 than what? Than x, because we know that if x is here in the number line, 3 is greater than that. Then we take this expression and make it our answer. So then it's -3x 3. So that is our answer. So therefore our domain is x such that x is between -3 and what? And 3. So when it's like that, our interval notation will just be that. Are we all on the same page?
Yes, ma'am.
Thank
Yes.
you. Okay. One last one before we move to what we need to learn for today. Okay, I'm tired. H of x is equals to x over square root of x plus 1. Now, let's see. Now that we have learned about domain x such that, what is the domain of this one? Look at it and look at it carefully. I think my handwriting is good here. Let me write it proper. So it will be x over square root of x plus 1. Think smart. Help me.
X
Yes,
greater x.
x.
X greater or equals to. Does we include the x plus 1 in the square root? Because anything below the square root must be greater or equals to 0.
Good. So what is anything under the square root in this case?
X plus 1.
X must be greater or
Before that,
equal.
what is that anything? Because we said anything under the square root should be greater or equals to 1. That's what we are saying. What is that anything? I don't want you to confuse yourself. Start there. We said anything under the square root should be greater or equals to 0. What is that anything?
Is x plus
X
1.
Plus 1.
Thank you. So you're saying x plus 1 is greater or equals to
0.
0, right? Okay. Is someone seeing something wrong there? I know you have it in your heart, but you're not saying it. Please say it.
Something wrong.
Guys, are we all okay with this answer?
Yes.
X may make equals to 1, but it's
We are saying that, please listen to this. We are saying everything under the square root should be greater or equals to 0. That's what we are saying, isn't it?
Yes.
Okay. Everything under the square root should be greater or equals to 0. Something is not right. Can someone tell me what is not right? Guys, what is not right there? Look at your function and tell me what is it not. It sounds right, but something is missing.
There's a restriction maybe when you say x must not equals to -1.
No, before that. Can someone ask a question? I know that you want to ask a question. Ask me that question. I know someone has a question in mind. Ask me that question. Now, please. Guys, this is an important session we have to do here.
Something.
Hmm?
No, ma'am, I'm not seeing anything wrong. Ma'am.
You're not seeing anything wrong.
No.
Okay,
Oh,
now I'm being honest. This
like,
is wrong.
okay. It's wrong.
Find what is wrong.
Is it in the original? I mean, original function or in a domain?
Look at your function and tell me what is wrong with whatever we have written in the domain.
Shouldn't it be x divided by x plus 1 is greater or equal to 0?
So
Yes.
the domain is correct, or is the function is wrong?
The function is fine, but our domain sounds right, but there's something we are missing here. Look at the function and look at our domain. We only focus, yes.
Square root of x plus 1 is not equal to 0.
Did you hear that?
No, please repeat.
Why?
Square root
Yes?
of x. Square root of x plus 1 is not 0.
Why?
Why is not 0?
Why?
And
Why not 0?
Because it's going to be undefined. A division by 0 is undefined.
Did you hear that?
Yes,
Guys, did you hear that?
But I'm still confused. A division by 0 is...
Remember what we said.
Oh, which means it is not equals to 0.
So it's what?
It's not equals to 0.
So what will be the new domain?
X plus 1 greater than 0.
Thank you. You only focused on the square root, but you didn't focus that square root is a denominator. So it cannot be equals to 0. Do you see that?
Oh, yes. Yeah.
You were right. Anything under the square root should be greater or equals to 0. But now our square root is a denominator, so it cannot be equals to 0. Therefore, this part is not allowed. Does it make sense now?
Yes.
You
That's
look at the whole equation and then you start solving. So this is x such that x should be greater than what? Greater than -1. Huh? Something is not. X should be greater than -1. Yeah, it's fine. I'm just tired. Because then if your x was equals to -1, you put -1 here, it was going to be x over square root of 0, which makes it x over 0, which makes it undefined. That's why then we focus on the square root and also focus on where the square root is. Interval notation, I'll just write it. So this will be, they're saying all x is greater than 1. So -1 is here, not included. So it means greater than 1. So it's -1 and positive infinity. Are we all sorted there?
Yes.
Okay. Do you need 5 minutes?
yes, please.
Please. I hope you are promising that next week's won't drag, ne?
No.
Ma'am, when
Thank
will
you. It means
be
you'll come
our
prepared.
next- when will be our next discussion class?
It'll depend on you.
Or should we ask it for it?
You don't ask for it. It will depend on you. How many are you today? Let's see. 1, 2, 3, 4, 5. Are you 6? 1, 2, 3, 4, 5, 6. If I
7.
get 7,
No.
Yeah.
Yeah.
it's 6.
36. Okay.
If I get 6 submissions
Mm.
of the homework, 6 submissions of the homework, let me give you, by Monday, you are getting a discussion class next week.
And I'm not only speaking for myself. Can you like, guys, can you please like on Monday have another discussion, because like we are really lacking on some, like we read our notes, but we miss few steps you know, when we are solving, and that will cost us in a final exam.
Rashid, listen to this. Those who attended discussion, you are here in this discussion class because of those who attended discussion class last week. Last
Yes.
week. Does it make sense?
Yes.
So it means that if I get 6 submissions, there are 6 people now. I'm talking to 6 people, right? If I
Yes.
get 6 submissions of the homework by Monday, you'll have a discussion class. If I get 12 submissions, double the number, it means you have 2 discussion classes. That's how it works.
So how do you submit?
You write your homework, take a picture, send it to my email. That's how you submit it.
Okay.
That's how it works. And I'm going to tell your friends as well. If you get 12 submissions, you have 2 discussion classes next week. Last week, we didn't have a discussion class because the submissions that I got, they were late. So by Monday midnight, when someone submits, I'll write in this chat 1, 2, 3, 4. So you tell the others as well. So you write, you take a picture, you send it to my email. So if I get 6 submissions, 1 discussion class. If I get double the submission, 2 discussion classes. So discussion class depends on you guys, not me.
Right. So the homework, will you send the homework on our emails?
I'll send it. I'll check if my unit is still on. But I will type it here again. I did mention it at the beginning, but I'll type it here again.
Okay.
Thank you. So it's based on the work that we're going to cover here. So I'm giving you 5 minutes. Oh, today's session dragged. I'm giving you 5 minutes. I think maybe we can leave this meeting so that we have 2 videos instead. Because no one would watch a 2.5 hour. Is that okay?
Yes.
So
Thank you.
you are giving us 5 minutes break, and then you'll come back.
Yes.
You'll resend the link again.